Hey guys, it's Miss Smith. We're doing Unit 10-3 surface area with nets. Now today we did nets, so we should know a lot of things about going from a 3D figure to the net view. Okay, so first of all, what is surface area? Let me get my pen out. What is surface area? Surface area is the sum of all areas on the outside of a 3D shape. When we create a net view, like we did today with that graphic organizer or the chart, okay, when we create a net view of a 3D shape, it becomes 2D. So therefore, we express surface area in square units. And it makes sense because it's surface area, right? So we're going to be doing all our units. Instead of having it cubed, it's going to be units squared, just like area, okay? Now, let's talk about lateral and total. These are the two definitions we have to know. So when we're talking about lateral surface area, we're talking about when we change a 3D figure into a net, we do not include any of the bases when we're adding our areas together. Okay, so we're going to express lateral surface area as LSA, because we don't want to write that every single time, of course. So what do you think our lateral surface area would be for this shape? And what is this shape? Good. It's a triangular prism because it has three rectangular faces and two triangular faces. So we know it's a triangular prism. So the lateral surface area would be adding all these areas up, but we're not including the bases. So we would add our three rectangles and not include the bases. Okay? So what we're doing, guys, is we're adding, just like we did with composite figures, we are adding all our areas up to get lateral surface area or total. So let's go to total, and we'll talk more about real life examples in just a second of what surface area means to you. But let's talk about total surface area, TSA, we're going to abbreviate. Okay, so all areas of the net view, okay, we have 1, 2, 3, 4, 5, 6 areas right here. Okay, so all areas of the net view added together, they're going to include the base. Okay, so we're going to get the areas of every single area as a net view. So this going to the net view, we're going to do every single area. So total means the word total area. Okay, so what does surface area? Oh, let's do that in a second. Okay, so let's practice shading. Okay, let's shade just the lateral surface area of this shape and think about what is this shape. Good. It's a square or rectangular pyramid. Okay, it has one rectangular base or square base, and it has 4 triangular faces. Okay, so what does LSA mean? Lateral surface area. So we are adding all our bases together, all our areas together, but the base. So we would add all 4 of these triangles together to get lateral surface area. To get total surface area, then we would include the base. Okay, so let's go to our next shape. What is this as a 3D shape? Since this is the 2D net, and yours is really light, but there's a triangle right in the middle. I knew you'd get it right. It's going to be a triangular pyramid. Okay, which we learned all this today. So I want to get the total surface area. Well, that's easy. We're going to get area of this triangle plus area of this triangle plus area of this plus area of this. Good. Okay? If we were just getting lateral, we would not include this middle base, correct? So lateral surface area means adding all the areas but the base. Okay, let's go to the next one. What shape is this? Good. It's a triangular prism. Has 2 triangular bases and 3 rectangular faces. So I want the LSA of this. So I want the lateral surface area. I need to get it right. Good. We're going to add all of our faces. We do not include the bases with lateral surface area. Okay, so what we need to know to calculate surface area. Okay, before I say the first two here, I'm just going to go ahead and say this. What does this sound like? You've already done it. Exactly. I hope you just read this. It is how to solve composite figures. So all you're doing is adding all the areas up just like we did with composite figures. This is exactly like it. We just have to know our vocab. Is it lateral? So we exclude the base. Or is it total? We include the base. So that means we get everything. So other key things from your formula chart, you need to understand how to find area of all 2D shapes. Obviously, because, if we get thrown a triangle, we need to know how to find the area. If we get thrown a rectangle, we need to know how to find the area. Okay, and so we also need to know how to identify 3D shapes to create a net view. So if they give us a 3D shape, we need to know what the net view would look like from the definition of what that shape, bases and faces is. Okay, real quick, we're almost done. I think y'all are going to get it really easy. Okay, so connecting it to real life. Surface area is different from volume because surface area is like wrapping a present. Okay, it's the outside of an object, of a 3D object. Okay, so if I took the wrapping paper off, I could make a net view. But if I put it back together, I would have a 3D figure. Volume would be the stuff inside of the present after you wrap it, because volume is the capacity. It's the amount of space something takes up. So surface area is like the outside of something. Okay, it's like the shell. All right, so we are going to find our LSA, which means our lateral surface area. Oops. Okay, so I'm going to go over here. Here's my question. I want to find lateral. Well, I drew it for you right here. So let's see how I got to 48. Okay, so we need to know all our sides. There's 3 different sized rectangles it looks like, because we're not including our bases with lateral. So this would be a 4 by 5. So base times height of this one would be 20. Okay, now when we do surface area, I want y'all to write the area inside of each one and then add them all up. Okay, so what would my base and my height be of the middle rectangle? Good. Well, if I know this is 4, this is going to be 4, and this is pointing to this, so it's got to be a 4 by 3. So this one has to be base times height. Good. It would be 12. So this one's 20, this one's 12. Now we got to figure out this one. Well, I know from this side length and this side length that this has to be 4. So 4 times 4 for this one has to be 16. Okay, so I had 12 right here and then 16 over here. All right, now I'm going to go ahead and erase our side lengths so we can just focus on the 3 areas. So let's see if it gets to 48. So we have 20, adding all our areas together, plus 16. 6, 7, 8, 2, 3, 4. So 48 centimeters to the second power because we're doing areas. Easy? So this would be our lateral surface area. All right, now let's go to total. We already have our lateral. So what are we just going to have to add to 48? So we can start out with 48 since we already got lateral surface area. So what do we need to include now for total? Good, we need our bases. Okay, we need our bases. So our bases are going to be the same size, always. So I'm going to find what the area of a triangle is. So look on your formula chart. Good, base times height divided by 2. So we have 3 times 4 divided by 2, which would be 12 divided by 2 would give me 6. So I know this is going to be 6, and this is going to be 6. So let's see if we get 60. 48, let me rewrite 48 over here. 48 plus 6 plus 6 is 12. We get 4, 5, 6. We get 60 centimeters squared for the total surface area. That's about it, guys. You just got to know what total surface area is and what lateral surface area is. And we've already done this part because we did all this adding areas up in composite figures. So should be pretty easy. All right. See y'all tomorrow. Make sure you scroll down and do the quiz.